Okay, so now we're in the section about Booleans. Okay, I'm going to break some things down in this particular section because I know it's some things that you've probably never been introduced to, but I want to kind of hit it home for you, and I'm going to plant some seeds in your mind that's going to come out later when we go over this more in depth. But I want to kind of introduce some things to you now to kind of help you understand Booleans. We've already gone over strings and numbers. Now we're going to go over Booleans, which is another primitive data type. So if you are coming to this channel and you're just seeing this video and you're not a part of the cohort, go ahead and click the link in the description for the curriculum and you can follow along. It's free, won't cost you anything. Okay, so let's get into it. So here, Booleans. One of the core features of any programming language is the ability to conditionally execute a segment of code. Pay attention, we're talking about a segment of code. We write things in small chunks, believe it or not. Programs is just made up of small segments that make a big picture. Basically, think of it like pieces of a puzzle. They're small pieces, but when you put them all together, it makes one big picture. This means that a program will run a segment of code only if a given condition is met. Example. Consider a banking application that can remind you when a bill is due. The application will notify you that a bill is due soon, but only if the bill has not already been paid. The condition for the above example is send a notification of an upcoming bill only if the statement if the bill is unpaid is true. In order to state something like this in JavaScript, we need to understand how programming languages represent true and false. Boolean values. The JavaScript data type for storing true and false values is Boolean, named after the British mathematician George Boole. George Boole created Boolean algorithm, which is the basis of all modern computers arithmetic. There are only two Boolean values, true and false. JavaScript is case sensitive, so the capital letter true and the capital F of false are not valid Boolean values. So they have to be lowercase like this right here to be true Boolean values. Now here we have an example. We're console logging true, and then we're asking for the type of true and the type of false, and it lets us know that it is a Boolean. So let's do this. Let's go over into our trusty inspect tool. Let's click on the console. Let's clear this out, and I'm gonna copy this and we're gonna paste it in. So we're gonna right click and paste. Now when I run it, I get the same thing, true and a Boolean because I'm doing the type of. I want to know what the type of true is, and it's telling me that it is a Boolean. Okay, you understand that? Now, the values true and false are not strings. They're not strings. If you use quotes to surround Booleans like this right here, true and false inside of a quotes, those values become strings. Now remember, I said think like the compiler. The compiler recognizes that opening quote and is looking for a sequence of characters and is looking for an ending identical quote. So an opening and a closing quote lets the compiler know that it is a string. The compiler understands when it sees the true without the strings, like up here at the quotes, and the false without the quotes, that they are Booleans. That's how we get the type of right here. Now, here's another example. we have a console.log type of true, console.log with this true inside of the quotes. When we do that, we know that it's Boolean and it's strings. Now, let me ask you a question. What is this called right here? Think about it. We told you what these are when we talked about the numbers and the strings. What is type of? I want you to remember that. I want you to go back and I want you to look and say, okay, this is what type of is. Because as we go forward, I want to keep going over and reviewing things that you've already gone over so it can stick in your mind. So we got the console.log, Boolean, and string. Now, Boolean conversions. We have a Boolean conversion just like we have a number and a string conversion. Now, this part is where I kind of want to break something down to you because I need for you to understand all of this right here. So, what I want to bring up to you, and I want to kind of plant a seed into your mind to really help you understand what Booleans are. Well, Booleans is, like I said, a true and false. Now, how do the compiler know? Because it can't read true and false. It doesn't read it. It has to be converted to binary numbers. Now I'm going to give you a high level understanding of what that means because it's very complicated, so to speak, understanding binary numbers. There's a lot to it. So a binary number is zeros and ones. We call that base 2. Now let's compare it to something that you're already familiar with. You're familiar with base 10 because that's what you were taught in school. We were all taught base 10. And what is base 10? Base 10 is 10 digits, 0 through 9. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in base 10, when you get to the 9, as you add 1, we always count by adding 1. We know how to count without saying 1 plus 1 is 2. 2 plus 1 is 3. We just count 1, 2, 3. We add 1 to each one of the digits to move forward. But when you get down to the number 9, if you look at a table with the base 10 placeholders, you have the ones columns, the tens column, and the 100s columns. When you add 1 to 9, it's imaginary wall right there. It can't go any further. So it has to create another placeholder. So it moves that 1 to the next placeholder, and that 9 becomes a 0. In the ones column, it basically resets itself. So 10, add 1 is 11, all the way down to 20, 30s, the 40s, the 50s, the 60s, all the way down to the 90s. When we reach 99, we add 1 again. It's going to go and say, can I add 1 to 9? No. So it has to go over to the next column. Can I add 1 to that 9? No, because it can't go any further. So it goes again, and then notice there's an empty space in the next placeholder, which is the hundreds. And now is 1, and it resets those columns 0 and 0. So as you can imagine, we go add 1 each time till we get all the way up to 999, and it moves over to the next placeholder. Well, that's how binary numbers work when you count binary numbers. It's base 2. It goes 0, 1. So 0, I add 1, gives me 1. I add another 1, I can't go anywhere because it's an imaginary wall right there. So it has to go to the next placeholder. If it's empty, it adds a 1 there. So now I want to add another 1. So I can add a 1 to that 0, so it gives me 1, 1. So now, when I want to add another 1, I'm going to go I can't add another 1 to the 1 because there's a 1 there already. So I go to the next one. There's a 1 right there. So I go to the next placeholder, place my 1 there, and then the other two columns are reset back to 0. That's how binary numbers work when you're counting. So 0 is 0, 1 is 1, 1 0 is 2, 1 1 is 3, 1 0 0 is 4. So now you may be wondering, how in the world have we created complex algorithms and software with just zeros and ones? I'm going to give you a word to think about. I'm going to plant a word in your mind: patterns. See, one digit of a binary number is a bit, B-I-T. And it takes 8 bits to make 1 byte, B-Y-T-E. And it takes 1,000 bytes to make 1 kilobyte. And it takes 1,000 kilobytes to make 1 megabyte. And it takes 1,000 megabytes to make 1 gigabyte. And it takes 1,000 gigabytes to make a terabyte. This is something you understand. But there's a pattern here because those zeros and ones represent a switch. So let's think about a light switch. So another word I wanted to put into your mind, I'm going to plant into your mind now, like a seed, is the word state. We're going to deal with that later on. When we get into React, we'll talk more about state there. But 0 and 1 is like a light switch. Think of 0 because 0 represents false, 1 represents true. Also, it can represent on, it can represent off. 0 is off, 1 is on. So when we talk about state, when I walk into a room that is dark, the state of the room is dark. And so I may ask the question, if the room is dark, turn on the light switch. So that's a conditional, which we'll talk about later. But I want you to kind of get familiar with patterns, understanding that it's a pattern that we're learning and that we are going to learn about state in the future. But zeros or ones are a switch. So think about true and false like a switch. So if it's something is true, then we know that the number 1 is signed to true. If it's false, the number 0 is assigned to false. That goes back to the ASCII table, because how are we able to create all these languages and write all these paragraphs and these codes? Because a bit has a value, it has a Boolean, and it has, like I say, the true or false. It's a state. So it has a state, a value, and it has a Boolean. That's what a bit is. So in order for me to make these complicated codes, I have to set the switches. I have to set 0, 1, 0, 1, 0, 1, but I can only have 8 switches inside of to make up a byte. And so I can have up to 255 or rather 256 type of alterations here, where when you think about that number 256, you're familiar with that because we use 256 colors. We talk about 256 gigabytes. We've seen that number before. But when it starts off at a binary number, to make up those 8 bits, it starts off with 0, then 1, and then it doubles to 2, then it doubles to 4, then it doubles to 8, then it doubles to 16, then it doubles to 32, 64, 128, 256. And your keyboard, all those symbols fall within that 256, where you can have 256 symbols. So the capital A has its own binary code. The lowercase a has its own binary code. And like I said, it all starts off with 0 and 1, true and false. False is 0, 1 is true. I hope that I'm introducing this to you. It may not make sense right now, but the more and more I go over this, I'm going to reference that. Okay? So here, back to the curriculum. This is why I kind of wanted to break that down to you, because when you look here, We said explore how Boolean converts various non-Boolean values. When we look here, this is the Boolean conversion. This is the function, a capital B. So that means that this is a function you didn't write. This is abstraction, but it works. It's going to convert this true that's in quotes, which is a string. It's going to convert it to be a Boolean, which would be true. And it can do that because the compiler knows that this is true. These letters are TRUE. That binary code matches. The same right here. It knows this function is written to understand this binary code as well. But remember, like when I said 0, 0 is 1. I mean, 0 is false. 1 is true. Now, this empty string, this is considered false. And this right here, launch code inside the string, is going to convert it to true. So let's go over here. Let's inspect that. Let's go to the console, clear that out, put this in, right click, and paste it in, and let me run it. You see, like I said, true is now true, true, false, because 0 is false, true, because remember in the binary 1 is true, false is an empty string, and then launch code. But now this talks about truthy and falsy. Now I'm going to take you over to MDN. Here, I'm gonna leave this link for you so you can go here to MDN and look and just type in truthy. Truthy in JavaScript. You could type it in, and I'll leave a link in the description, and you can read this. And this is one of those things you're going to want to bookmark. In JavaScript, a truthy value is a value that is considered true. When encountered in the Boolean context, all values are truthy unless they are defined as falsy. That is, all values are truthy except false, 0, -0, 0n, an empty string, null, undefined, and not a number. Those are all considered false. So that's why I wanted you to see that, because over here we're showing you that true, this turns into true because the ASCII code, the binary numbers are given to each one of these letters. This function knows how to use an expression to find it and understand it. But remember, this 0 and this 1, 0, when you see a 0 like that in Boolean, it's going to turn it to false because 0 is false. The empty string is false. And launch code is a string. The reason why it's true, because everything is truthy except for those few characters that it showed you: 0, false, undefined, null, not a number, NaN, empty string, O of n or 0n, and that's when we get into data structure, so don't worry about O of n. So that's why I wanted to kind of break that down to you. This video is getting long. I'm going to stop it right here, and so you can kind of chew on this and get an understanding of what we just talked about, and then I'll pick it back up in the Boolean expressions. So again, you got to practice this. The more you do, the more you're going to improve. So I'm going to stop the video here, and we're going to pick back up in Boolean and give you a little break. Okay, see you in the next section.